Okay, there you go.
All right. Well, welcome everybody, and thank you so much for joining us. It is my pleasure to welcome Professor Daniel Farber. So he is the Sato Professor of Law at the University of California, Berkeley, and he has leadership roles at two Berkeley research centers: the Center for Law, Energy, and the Environment, and the EDLI Center on Law and Democracy. Professor Farber is a member of the American Academy of the Arts, and he is a graduate of the University of Illinois. He earned his BA, MA, and JD degrees from there. He graduated summa cum laude from the College of Law, and he was the class valedictorian and served as editor-in-chief of the University of Illinois Law Review. After law school, he was a law clerk for Judge Philip Tone at the U.S. Court of Appeals for the Seventh Circuit, and then for Justice John Paul Stevens of the U.S. Supreme Court. Professor Farber practiced law with Sidley and Austin, where he primarily worked on energy issues before returning to the University of Illinois as a faculty member in 1978. He taught at the University of Minnesota Law School from 1981 to 2002 and was the Magnite Presidential Professor of Public Law. He also has been a visiting professor at the Stanford Law School, Harvard Law School, at the University of Chicago Law School. His most recent book is Contested Ground: How to Understand the Limits on Presidential Power. His earlier books include Research Handbook on Public Choice, published by Edgar in 2010, Judgment Calls, Politics and Principle in Constitutional Law, and Retained by the People, The Silent Nine Amendment, and the Rights Americans Don't Know They Have, among others. So please, thank you so much for joining us, Professor Farber, and we look forward to your presentation. So a very minor note on the housekeeping. So we're going to be leaving the questions for the end. We encourage you, like if there's some questions that you would like not to forget or that you would like to keep them present, please add them to the chat. And then at the end of the presentation, we'll go over those. So Professor Farber, the floor is yours.
Well, great, thank you. Let's see if I can share my screen. It was a little glitchy when we tried it out earlier, but I think that we have. Okay. Let's see. Okay,
Perfect.
are you
Yep,
seeing it? Great.
yep, perfect.
Yeah.
Okay. So what I'm going to talk about today is data center regulation, uh, which obviously is a big issue right now for reasons that I'll talk about shortly. Um, so there's a lot to say about AI. Depending on who you ask, it's either going to save us or destroy us. It'll either create unbelievable wealth for everybody or crash the economy. But it's also an explosively growing industry that requires massive infrastructure. Regardless of what's sort of going on in terms of the AI itself, we're just talking about a huge building spree involving not only, the buildings themselves and all that goes with those, but of course, all of the massive number of chips and other things that make the AI work. So what I'm going to talk about today is the infrastructure, the physical side of things, the data centers, the water and electricity they consume, and the environmental burdens they can create. Um, what's actually happening with the AI itself is another matter, but the AI won't actually be there unless we do all this building to make it happen. So I'm going to start by talking about a little bit about why this is presenting a major challenge to the sort of regulatory system. And I think you can sort of see the basic reason on this slide. Basically, we went through a long period of time, actually going back well before 1989, in which electricity demand was constantly rising with, some ups and downs with the Depression and World War II and then the end of the war and so forth. But basically a period in which you could assume continuing growth in demand, which meant continuing growth in the number of generators and the grid and so forth. And that was until 2007. And then, or it says here, I would say actually 2005. And then we had almost 20 years of pretty much flat demand, building new generation only to replace old generation as it became outmoded. Um, And then all of a sudden, that's changed again, and we're back to growth. And so that rapid change is what's causing some of the issues. So here, what you can see, if you look at, say, 2005 to 2025, um, there's some ups and downs, but basically it's not statistically different from just a flat line. And then all of a sudden that's changing. Um, Data centers consumed 176 terawatts in 2023, but that's projected to double by 2028, which is a very short period of time as these things go. Um, we're going to need something like $50 billion in grid infrastructure investments. That's not the generation, that's the wires, basically, and the transformers and everything else that makes the grid as a whole work. And the problem is that utilities usually plan things over 10 to 15-year periods. And now all of a sudden they're being faced with the need to adjust to things that are happening on a 2 to 3-year cycle in a very big way. And that also puts strain on the regulatory system. I'm not going to go through this whole slide. If I were like teaching law students, I would want them to understand all the specifics of this. But I think what's really important for you to understand today is just how these areas of federal authority are distributed among a lot of different agencies. So we've got the primary areas of federal concern are electricity regulation, nuclear power, environmental stuff, federal lands. And what you can see is there's not like one central agency that's in charge of this stuff, right? I highlighted in blue the different agencies involved. It's kind of an alphabet soup. So like we have FERC, which is the Federal Energy Regulatory Commission. We have the NRC, Nuclear Regulatory Commission, DOE, Department of Energy, EPA, which you've all heard of, Fish and Wildlife, the Army Corps of Engineers, which most people don't really think of as being an environmental agency, the Interior Department, the Department of Energy again, for other kinds of activities. So what you can see is there's just a whole bunch of different agencies. And even within these agencies, there are different groups of people who work on different problems, like the air people and the water people at EPA are actually pretty separate. So there are really kind of two sub-agencies there. The White House, in theory at least, coordinates all this, but they've got limited capacity. They can't oversee all of this and micromanage everything. So a very difficult ship to steer. And that's the federal authority. But there are also areas where the states are in charge. If going back to this slide, you'll see I said electricity regulation. Well, transmission and wholesale transactions are under federal control. That's the first line here. But as you see on this slide, the generation, local distribution, the wires that come into your house or apartment building, retail sales, the bill that you get in the mail, or online, I guess, these days, those are all under the control of state utility commissions primarily. But some of it could be under the control of cities or under the control of, for example, some aspects of generation may be under the control of a different agency. In California, we actually have one agency, the Energy Commission, that's in charge of planning new generation, and the Utility Regulatory Commission that's in charge of the rest of this picture. So we have a division in electricity regulation between federal and state regulators. For water, water pollution is federal primarily, but everything else about water is state. So, for example, whether you're allowed to pull water out of a river or out of the ground in order to use it, and how much you're allowed to use, that's all state law. And land use is state law. Zoning, land use permits, building permits, et cetera, et cetera. Sometimes not even state law. It's sometimes often devolved down to cities or counties. So we have a very fragmented regulatory system, which is always somewhat problematic, but especially problematic when you're trying to make something happen quickly. So let me just give you a minute to kind of absorb all that. And then we have the political side of things, which is also an important part of the background. So one starting point is that Americans are not especially enthusiastic about AI to begin with, right? This is not an area where, as a country, we've come together and said, yeah, we got to build out AI as fast as we possibly can. It'll be great. Or, we need it for national security. We just got to do it as fast as possible. No, this is something that a lot of Americans feel pretty iffy about. And if anything, seem to be less sold on than they were earlier. So you don't start out with a groundswell of support for the idea that, rah, rah, we're going to have an AI data center. Environmentalists are worried about data center impacts. I'm going to talk more about those impacts in just a few minutes, but there are a lot of them, right? They're not incredibly huge necessarily for any individual data center, but there are going to be lots and lots and lots of data centers. You add it up, it's a pretty significant impact on all kinds of, air pollution, potentially water pollution, depending on location, could be on ecosystems, et cetera. So there's a lot of concern there. Rural populations, where a lot of this stuff is going to go, seem increasingly resistant to major infrastructure projects in general. I mean, this has been a problem for people who want to do big solar farms or big wind farms out in the countryside. There's a lot of pushback these days. So far, $64 billion in data center projects have been blocked or delayed across about half the states. And I'm sure the figure is higher now. I think this figure that I'm using is probably 6 months old, right? So there've been a lot of projects that just have not been able to get off the ground because the locals don't want it. And I think that's somewhat understandable because the projects basically, are not going to create long-term jobs in these areas and are, any benefits are really probably going to come in the form of expanding the tax base or something like that, which is, good, but it's not a tangible kind of benefit. And while all this is going on, there's also a battle going on about the whole permitting and regulatory process, which you can see, pretty much on any day you want to on, whatever news source you're looking at. There's some battle going on between the Trump administration and somebody else over some effort to deregulate and eliminate some part of the permitting process or to deregulate some part of the environmental regulations, right? So all that's going on in the background too, and some of what's going on with the data centers is getting sort of pulled into that. Okay, so that's like a view from 30,000 feet, and now I think we can take a sort of closer look at what's going on. Just to sort of summarize what we've been seeing, what we've seen is a shock to a system that has been really calibrated to deal with a certain kind of problem, which is, how do you most efficiently and cheaply and maybe environmental and maybe sustainably, at least in some places, deliver power, a fixed amount of power to the population, to all of a sudden being faced with the need to do a huge build out and adjust the system accordingly. And one of the things that makes this difficult is not only a huge surge, but it's an unanticipated surge, right? 4 or 5 years ago, nobody knew this was coming. Nobody knew that AI was going to suddenly take off in such a big way. So there hasn't been much time to even plan for the surge. We got fragmented governance across federal, state, and local agencies, which creates all kinds of difficulties, and it means that there are a lot of friction points where the process can get slowed down. And then there are just plain process issues. Permitting is a notoriously slow and clunky process. If you've ever, just getting, a permit to build an apartment building is very difficult in many big cities, for example, and takes, quite a bit of time. Um, Putting up, another skyscraper in Manhattan that's like all the others, you don't just walk in with your permit application one day and they stamp it and then you're done, right? It's a big deal. And so what we've got is a permitting process that's kind of slow and clunky, maybe necessarily so, but we don't have just one. We have different types of permitting and approvals going on in many different places, at different levels of the governance system. So you can see, like, if you're a project manager for one of these, data center build out, I've never talked to these people, but this is a big job. And managing these projects has got to be a big job, even though in some sense, architecturally, they're pretty much all the same building over and over and over again. But that doesn't make it easy. Okay, so I want to now slow down a little bit and take a closer look at permitting issues. So, as I've already said, these data centers require a lot of new electricity generation. And so we're not just talking about permitting for a building, the data center itself. We're talking about permitting also for whatever kind of generation facility is going to be supplying the power. And there aren't a lot of places where there's a huge amount of slack generation that you can just plug into. So we're really talking about new generators, whether it's nuclear, coal, gas, solar, wind, uh, you know, geothermal. Somebody's going to have to approve the construction of a new plant. A new nuclear plant has to go through licensing from the Nuclear Regulatory Commission. Historically, that's been a very lengthy process, although the Trump administration is doing its best to dramatically accelerate that process. New fossil fuel plants are going to have air emissions, and so they fall under the Clean Air Act. The Clean Air Act is a really complicated law. I think the current version of the law runs about 300 pages in small print. And so when I say, oh, well, it has to go under the Clean Air Act, maybe that sounds simple, but it definitely isn't. There are a lot of complicated requirements that have to be met. You have to comply with requirements about the emissions from the plant, but those can sometimes vary depending on plant location. And you have to get a permit, which means that there actually has to be some kind of review before, in principle, at least before you can even begin construction, let alone start powering up and generating electricity. Fossil fuel plants also require cooling, and that itself gives rise to regulation. Just pulling water out of a lake or a river or the ocean to use for cooling is under a separate permitting process under the Clean Water Act, right? So just for the power plant itself, you've got this additional track going on. if you're using fossil fuels. And then there's water pollution, right? So the water pollution for the data center itself is significant. Um, uh, Data centers can be air-cooled or water-cooled. If they're doing water cooling, it goes through multiple cycles, right? It's not one and done. They pump it through and then they recycle it, cool off the water, send it back through the system again, etc. As it goes through multiple times, it starts picking up or concentrating pollutants. What that means is that you're going to have to do something about the water pollution. You either may have to, if it's going into a municipal treatment system, going into the sewer, basically, it may require pretreatment before it can even go in if there are like toxics or metals in it. And if you're putting it back in the river or wherever it is you got the water from, you need a discharge permit, just like any other industrial polluter. So again, you're going to have permitting issues. In addition, if you're putting it into the local system, there may be enough volume in some areas, if you're moving into an area that doesn't have a lot of volume to begin with, that it's going to require upgrading the local municipal treatment center or increasing its capacity or something like that. And again, and that's going to, obviously involve a dispute about how much of that needs to be done and who's going to pay for it. Right, so we have this fairly complicated set of concerns, and all of which, is potentially contestable, right? It's not like this is all cut and dried. Everybody agrees on what, immediately on what is required to get the permit. The people applying for the permit have an interest in trying to minimize requirements to save money. The permitting authority may or may not be sympathetic with that idea. There could be environmental groups involved or community groups. So this can all of this stuff can get quite conflictual. In a way that probably wouldn't be true if, say this was a situation where, we were deeply committed to, I don't know, if this was all part of some ongoing war with China or something like that, where we absolutely needed to build this stuff, it'd be a lot different. But we don't have that kind of political support that would allow you to sort of bulldoze your way through all of these concerns. And we found out even from World War II, where that was true, that we now are still cleaning up some of the radioactive contamination they left, what is it, 80 years ago now, in their haste to, not worry about safety issues and just get the job done. So what about water use? This has actually become quite controversial in some places. I don't go into like individual cases, but for example, there was a data center killed in Arizona over the water use issue, and I think I know of at least one or two others, two places where that's happened. Um, because a fair amount of the country, everything sort of west of the Mississippi, water is constantly an issue. East of the Mississippi, it can be an issue, at least from time to time, droughts in Georgia and so on. So data centers currently consume about 17 billion gallons for cooling. That was in 2023, so a higher number by now because we've already had some expansion. Now it says approximately, and that's not because I'm rounding off, but because we don't actually know the exact number. Data centers have been claiming that the amount of water they use for cooling is a trade secret, and that they've been refusing to disclose it to anybody. In fact, they've successfully fought off legislative efforts in some states to require disclosure. I'm really a little baffled by the trade secret claim. It seems like the amount of water you're using shouldn't be something that's, desperately confidential, but maybe there's stuff I don't know. Um, um, Now that may be changing. There was a settlement with Google over its data centers that's requiring disclosure, and that may kind of help sort of eliminate that logjam and allow us to get better data on how much water the centers are using. Now, that's really the amount that the data center itself is using, but if it's getting electricity from fossil fuel for thermal sources, basically fossil fuel or nuclear, there's a lot of water being used there for cooling. And the amount that's been attributed to data centers from that electricity generation is about 211 billion gallons annually. So it's a lot bigger, right? So and there's kind of a trade-off, right? You can have an air-cooled center, which doesn't use water for cooling. So you get that first number down to zero, but that requires a lot more electricity to run the cooling system. And if you're getting it from thermal generation, then that's going to be using maybe even more water for cooling purposes. So the water is going to have to come from somewhere, right? And again, this is happening at a time where water issues are becoming increasingly pressing in many parts of the country due to climate change, at least in some places. If you may not have noticed this, but there's like a huge issue with the Colorado River, which has been in a 5-year drought, and the water is getting low enough that they're having to do some emergency actions to make sure they've got enough water going through the turbines to generate power for Las Vegas, right? So taking a bunch more water out of the system is a big deal. And that's, I guess, another point I want to make. I mean, your reaction to this, depending on your politics, might be, this is all just a bunch of red tape. We ought to just ignore it and go ahead. But it is red tape, but it's also responding to very real impacts, right? You could get rid of whatever regulations you have on access to water and just let them grab all the water they wanted to. But the fact would remain that there are water scarcities, and doing that is going to have some significant costs on other people, on other companies, on urban populations, on farmers, etc. Another point I want to make, and it's something you have to be careful about when you see numbers, like in the news sources. These numbers are for consumption. This is the amount of water that disappears, right? Basically evaporates due to the cooling process. That's a fraction of the amount of water that's pulled out and runs through the system, right? Evaporation losses are not, are substantial, but they're not 100% or anything like that. So basically, we are, we're pulling out, well over 10 times as much water out of rivers and streams, using it for cooling purposes and putting most of it back. The numbers I'm talking about here are only the losses as you go through that system. And the reason you have to be careful is that people will mix those up and start talking about the amount of the withdrawal as being the amount of water that's used up, which is very misleading. So, where do things sort of stand on all this right now? Well, um, I think I can probably assume that everybody knows that Trump is very big on fossil fuels and energy dominance. And so the policy of the administration has been to do everything possible to encourage the use of fossil fuels and accordingly everything possible to discourage the use, well, I would say and nuclear, and discourage the use of anything else like solar and wind. And in order to make that work, as a general matter, they're trying to deregulate and eliminate restrictions on fossil fuel generation and on nuclear, and to speed up the process. And speeding up the process often means minimizing public input because that's a serious source of delays when you have to stop and listen to the public and try to respond. The cooling water, even if regardless of where you're getting electricity from, the data center itself requires cooling. That's going to require permitting for withdrawal and at the discharge end. And then something I haven't really talked about, this sort of assumes you've got an entirely private project. It's on private land. It's not getting any public money. It's, et cetera. That's not always going to be true. Some of this stuff may well get built on public land. The administration is actually trying to encourage that in order to speed things up. But when you're doing things on public land, there are different kinds of regulations, or with public money, the different kinds of regulations that come into place, requirements for environmental assessments, various laws that are intended to protect public lands or ecosystems on public lands, et cetera. So it's a whole new kind of universe of potential restrictions that could come into place. I actually had a couple of extra slides that I've skipped going to even more detail on this stuff, but I don't think you need to know all the fine-grained stuff at this point. I think it's more important to get a little more of a big picture view of what's going on, and you may already feel like this is an awful lot of detail. I'm hoping I'm at least giving you the impression that there's a lot of detail, because that's the basic takeaway point, right? This is just really complicated. It's not like I don't know, getting, I don't know, applying for your driver's license renewal or something like that. We're not talking about that kind of permitting process. We're talking about a really complicated process because we're dealing with complicated systems. So, wait, I want to go back and I want to talk about one more thing, which is interconnection. When you have a new generator or new generator source, another kind of permitting comes into play. You can't just build a generator, go to the nearest transmission line, and I don't know, splice it in, right, and go merrily along your way. The grid is a really huge, complicated, interconnected system, and they have to make sure that adding your new generation source isn't going to screw things up, right? Isn't going to burn out a transformer somewhere else, at some point, or overheat a power line, whatever, right? And doing that isn't simple. So that's another sort of permitting pressure point, and one that's been very seriously delayed, and I'll come back to that later. But that's a real slowdown point in the system that's been bedeviling renewable energy projects, for example, for years. Okay, so now let me go on. One of the big flashpoints politically has been about the impact of all of this on electricity rates. So I've mostly been focused on the environmental stuff right now, up till now. But just putting all of that aside, there's the fact that we're going to have to build there's going to be a whole bunch of new generation being built. They're going to often need to be new transmission lines or upgrades in existing transmission lines and distribution systems, et cetera. And somebody's going to have to pay. And even if you're not paying directly, if the demand for power is going up, and we didn't have regulators, the price of power will go up, right? That's supply and demand. The price goes up, that induces an increased supply, but that higher price is paid by everybody, right? If all of a sudden somebody starts buying, I don't know, let's say the Chinese come in and start buying 20% of the US orange crop. Orange juice becomes a really big thing and they want to buy it from here. Well, the price of oranges and orange juice is going to go up for American consumers because somebody else is buying a big bunch of it. Presumably the supply will expand, the price will come down, things will equilibrate, but it's going to be at a higher price point. And that is something that consumers are very worried about. The reason for that is, as you can see here on this slide, that more or less independently, I don't think much of what we're seeing on this slide is attributable to data centers because they're too recent. But what you've been seeing is that the price of power has been going up faster than prices in general. Right, we've seen since say 2023, we've seen almost a 10% increase in the price of electricity. Right, and so people are very aware of their power bills. Not quite as aware as they are of gas prices because they pass the gas stations every day that have them posted on big signs, but still they're very aware. They're already upset about it, and they're seeing AI centers as, making things just that much worse. So here's something from Brookings. I actually, I ended up deleting this slide, but I actually just asked Google's AI about the impact of data centers on power prices, and I got this actually very sort of strident thing about how much the costs were going up, right? So, which I assume is kind of reflecting what the AI is seeing out there in terms of what people are saying on the subject. And it actually was a bit exaggerated, which I thought was interesting. But it's very real. We're still short 49 gigawatts, despite a massive power increase, which means there's going to be, that's going to put price pressure on electricity. That's about 5% of total generation in the US, so it's a significant shortfall that's going to have to be made up with a lot of new building. It's going to be expensive. And the cost of new transmission and distribution infrastructure gets passed on to consumers through basically rate designs, which I'm not going to go into detail about, but also because in many places, data centers have worked out deals with utilities or with the state. States have tried to attract these data centers. So they have incentive packages that actually require them to pay less than the full incremental cost of all these upgrades. So, in fact, it probably, or at least it's not at all unlikely that some of the costs are getting passed on to to other consumers, and that's something other consumers are not happy about. I guess they'd be happier if they thought they were getting a big benefit from the new AI centers, but they don't feel that way. So I guess I need to explain this first line about capacity auction prices. In much of the country, wholesale electricity is deregulated, which means that the government doesn't set the price for wholesale electricity. Wholesale meaning from generators to utilities, rather than from generators to retail to users. Those prices are federally regulated in much of the country. There's an auction basically for, you put out a buy bid for the next, kilowatt. And, if you win the auction, that sets the price. It turns out that given the way the system is designed, that doesn't create quite enough of an incentive to build new generation. So a lot of the country, including the grid operator called PJM that runs most of the sort of in heartland, old industrial heartland of the country, sort of the old Midwest and into the mid-Atlantic states. They have a separate thing called a capacity auction, where basically people are bidding to fill projected system needs for new generation, and that has shot up, explosively in the last 2 years, right? So, in other words, it's signaling that there's a huge need for new capacity that is, going to cost a lot of money. In terms of what happens to consumers, we're all modeling at this point, so, subject to some limitations, but Carnegie Mellon, their model projects an 8% national increase in the cost of electricity. But Virginia, which for some reason has become like the data center capital of the world, it'll be 25% increase in electricity costs. Now, that could be significant for some other businesses that use a lot of electricity, right? So, we could actually see some sort of economic drag on non-data center industries because of higher prices. But it's probably it's most significant in terms of and most politically significant in terms of ordinary consumers. And one thing that's really important to know about power costs is that electricity is like costs are regressive, right? Poorer people spend a higher percentage of their income on both on directly on electricity and also on various things that require electricity to make. The reason for that is that higher income people either save more of their money or spend it on services that don't require a lot of electricity input. So the people who are proportionately hit the hardest by increase in electricity rates are lower income groups. And we may be seeing already, not necessarily because of the data centers, but just from the rising prices that I showed you earlier, there's also been a concerning surge in the amount of disconnects, right? People whose power is cut off for non-payment, right? Which seems to be kind of a signal of economic distress. And that can get worse if we see big power price increases. Now, this would be a political issue in and of itself, but it's also coming at a time where affordability is the political watchword, right? So politicians and apparently the public are very, very sensitive on these affordability issues. And that's, I think, one of the reasons why this has become such a big deal in terms of the data centers. I think in principle, this should be manageable. That is, I think it should be possible to match new generation costs required by incremental costs required by a data center, and shift them back to the data center. That's not as simple as it sounds, but conceptually it's fairly simple. right? It's you look at it's a cause and effect thing, and you figure out there's new generation required. Where is that coming from? And then you ship that cost back to the generator. And there are ways of making that simpler by requiring them to like contract for power rather than buying it on the auction markets. Other costs like upgrades in transmission and distribution systems and so forth tend to be difficult to estimate. And the benefits tend to be difficult because if you upgrade the grid to accommodate the data center, that upgraded grid could help other people too, say get more reliable power or get power more cheaply. And it could have ripple effects throughout the system because power gets sort of rerouted basically whenever a piece of the system changes. So that can be very complicated. And when we build new transmission, there are huge fights that can go on for years about who's benefiting from the upgrade and how much should they have to pay. Right. So that part is actually, I think, trickier than the generation part. The cleanest scenario legally, and I think it's something that at least some companies are trying to do for that reason, is you just, you build your generator right where you are. You connect it directly to the data center. You don't connect with the grid at all. So if your generation fails, you can't go to the grid for power. There we can easily match the costs with the data center, right? So we don't have this sort of these complicated issues. We may be able to avoid a bunch of permitting and stuff. On the other hand, although you're creating some legal simplicity and regulatory simplicity, the odds are that this is not going to be an otherwise optimal way of getting your power, right? Because you've ruled out 99% of the universe of possible solutions to getting electricity and, ruled them out at the beginning. And you're just hoping, the odds that the one you pick are the ones that actually minimize total costs or, impacts on the environment or whatever, it's probably not going to be true. And it's not always going to be practical anyway, depending on where you're siting and sort of, what the potential is for actually getting a generation built there. So I think this is a difficult problem, but it shouldn't be an insolvable one, except people don't trust the industry. The tech industry in general, which used to have fairly high public approval, is, gone down considerably. Faith in government is definitely not at a high point. And the affordability issue is very salient, right? So this could be actually very tricky to work out in any kind of way that gives people satisfaction. So I want to do two more things before I wind up the lecture part of this. I want to talk quickly about some of the policy initiatives that are taking place. There are tons of things in the pipeline, right? There are, I don't know, like 250 bills pending in state legislatures right now dealing with data centers. But of course, only a fraction will become law, but there's a huge amount of interest in this. This is President Trump at a session with industry leaders on some of these issues. So a lot of what's going on is in FERC, the Federal Energy Regulatory Commission, and they're very worried about the interconnection queue, which is the waiting list for consideration of your request to tie into the grid with a new generator or a new major load. They've directed PGM, I mentioned before, it's the biggest grid operator, to revamp its interconnection procedures for large loads. They want to establish a framework for co-location. Co-location is a little misleading because what it means is the data center is connected directly to generation, but it might not be on site. It may be that you run a bespoke power line from generation in one place to your data center, and come up with new cost allocation rules for transmission upgrades. And that's something that we need anyway. Right. So FERC is addressing this, not, not entirely coincidentally, because they're under a lot of pressure from the White House to do something about it. The White House has been active in July of 2025. There was an executive order calling for new categorical exclusions for data centers from NEPA coverage. What that means basically is that there are categories of things that don't require environmental impact statements that otherwise would. And so they're trying to get data centers out from under that coverage. That's somewhat helpful, but I think most data centers would not be subject to these environmental review requirements anyway, so I don't know how big a deal that is. And then also they're worried about the water pollution issue, and there's a plan to streamline that process basically, so you don't have to go through a real full-scale permitting process. But then more recently, last month, there was a White House conference on the affordability issues, and the major AI and hyperscalers agreed to build, bring, or buy new generation and cover costs of grid upgrades. So they would, the idea would be you would, be able to point to your specific generation sources that are going to supply the new power demand from your data center. And you're going to pay that full cost. There's also been a lot of concern, like what if we build all this stuff and we build new transmission and generators, et cetera, and then the AI revolution does not arrive as promised or on schedule, right? You can imagine a scenario where we end up overbuilding, and then it turns out the economics don't support it, or at least don't support it currently. Things close down. Now the data center is closed, so it's not using any electricity or paying anything. And yet you still have all that new transmission or, et cetera, that somebody's going to have, or a utility has built new generation plants. Who's going to pay for those? We had a huge problem with that with nuclear when the sort of nuclear build out stalled out after 3 Mile Island. And a bunch of utilities were stuck with half completed or even more than half completed nuclear reactors that they were never going to finish and that they had spent, hundreds of millions or billions of dollars from. Who's paying for that, right? So to avoid that kind of stranded asset risks, the companies are agreeing to continue paying basically, even if they don't end up, even if at some point the facility is closed or it never operates in the first place, right? So the pledge looks good. It's pretty broadly phrased. The devil is in the details. A lot of people are very suspicious that in fact, the companies are going to pick up, the full cost. But at least one of the things you can see here is that both the industry and the White House are very much aware of the sort of delicacy of the affordability issue. EPA is planning to speed up the air permits. Right now, you really can't do even groundbreaking stuff before you get your pre-construction permit. The idea is if you let a company, let's say we had a rule where you get to build the whole facility and then you apply for a permit. Well, it's going to be really hard to turn down a permit after somebody's spent, hundreds of millions of dollars or $1 billion in many cases building new generation. So to prevent that kind of fait accompli, we don't allow you to start building the thing until you get the permit if it's a major generator. But they're loosening the rules to allow more of the pre-construction stuff to take place before you actually have to go in and apply for the permit. They're also pledging to keep the public out of the process as much as possible legally. Again, public participation, people who show up, when you have public participation requirements, projects people don't surge in to support the project. It's people who don't like it who show up and cause trouble and, and raise difficult issues and, foment political opposition, etc. So the idea is to kind of minimize that. And in general, to sort of minimize the permitting air pollution process as much as possible. There's state legislation. I mentioned there's a ton of things in the hopper. Probably the most dramatic recent one just happened with Maine passing a moratorium on data center construction until November 2027. There have been various efforts to deal with rate issues in what I've got 5 states here with different kinds of regulations. Many of them kind of very tentative, dealing with the rates. Minnesota's got a separate water permitting requirement for data centers. South Dakota has reinforced the power of local governments to control data center siting. That's actually something I think that the industry is probably not crazy about because it creates more room for a kind of NIMBY, not in my backyard kind of opposition. The details of this legislation are really not terribly important for us today. But what is important is that there's just a lot of ferment going on. We're going to see a lot more coming out of the states dealing with various aspects of the data center permitting issues. Okay, so concluding observations. So in some ways, I mean, there's nothing really that new. I think we've got engineering people, so it'd be interesting to kind of actually have some numbers on this. But it seems to me like in energy terms, data centers, pretty simple machine, right? It takes incoming signals, it consumes a ton of electricity, and then it sends out new signals. And it's not like a nuclear reactor, for example, that's producing a kind of environmental problem that's completely unique and different. This is just a machine that uses a bunch of electricity, creates a bunch of heat. We've had a lot of experience with regulating electricity generation and use, including problems like air pollution, water use, grid regulation. This is not new. So what's different? Why are we all of a sudden worrying about what would otherwise seem like fairly routine environmental issues? And I think the answer relates to timing. I don't know that we've ever had a new industry arise so unexpectedly and expand so quickly. I don't want to say that too firmly because I'm not an economic historian, but it seems like although we had data centers, but the whole AI thing, until ChatGPT came out, people were really taken by surprise by how much that could do, and then ever since then, things have been kind of going crazy. The regulatory system isn't designed to move that quickly. We're also seeing this on the actual AI regulation side where nobody's quite sure what to do or whether we should do anything about regulating AI itself because it's such a new problem. The industries that support electricity infrastructure are not designed to move that quickly. One of the places where the system had adjusted to sort of static demand were the companies that make new gas turbines for power, for major power plants, right? So that industry had not been growing. If anything, had been shrinking some due to competition from renewables. And as a result of that, there's limited capacity, and now there's a huge backlog on new gas turbines. So if you wanted to build a major new gas-powered generation facility, you might have to stand in line and wait for several years at least just to get the machines. Another timing issue, this is happening while we have extreme polarization and conflict. So even agreeing on very simple things is really hard. And one result of the current situation is that clean energy solutions, which in some ways could be the fastest to implement, it's a lot faster to do a solar farm than it is to build a new fossil fuel generator or a new nuclear plant. So, you can imagine using a lot of solar and battery storage. Um, and that's been difficult because the administration's been doing its best to try to eliminate that. So, looking forward, some of the current environmental problems will get better over time. For, companies, because they can't get they can't get the generators they need to build new major natural gas facilities. So they are doing a bunch of, I don't know what you call them, kludges, I guess, like, using what are supposed to be emergency gas generation units, but they're using them, as their basic source of power. Or I've been reading they've been like using old jet engines and revamping them and to try to use them to generate power, which is, kind of a mismatch between what the engines were designed for and what you're trying to get them to do. All of that results in, more inefficiency and more pollution, but we should be able to replace all that with something better as we go on. We should, on the sort of tech data center side, be able to improve efficiency and reduce cooling needs. There's work going on constantly on that front. And we should be able to figure out the cost allocation things. These are not impossible. But I think the big thing that we have to worry about in this transition period where, we haven't really adjusted the system to deal with this is that we get locked into bad solutions, right? We're doing things very quickly. We're like, what is that? Moving fast and breaking things. And the problem with that is we may not be able to fix them entirely later. We could, we could end up building a system that, has, built-in problems that will then be hard to deal with later. So I think we need to be aware of that as we do these short-term solutions and try to avoid ones that will keep us from being able to implement better longer-term solutions. I've also been really pretty much talking as if, the big problem is getting the facility built and, plugged into the grid, and then you're done. But that's not going to be true. We're going to be having continuing regulatory issues and regulatory changes that will impact existing data centers over time. Clean air regulations, for example, have a tendency to get tougher over time, and that's going to kind of feed back to some of the data centers. And no doubt we're going to have economic and technological changes that are going to affect all of this. So basically, stay tuned. This is going to be a very dynamic area where we're going to be seeing a lot of things going on. Okay, let me see. I think I've successfully gotten out of share screen and surprisingly just on time.
Great. Thank you so much, Professor Farber. So I will now open the floor for questions. So the way that we organize this is like we will give priority to the questions from students, and then we'll open the floor to questions from the general public. So, if students want to start with some of the questions that you may have regarding the presentation.
Hi, I have a question. My name is Selena and I'm part of the ESE program. I was wondering, I know we talked a lot about the physical building part of AI, the regulations around it. Do you have any opinions on regulations around AI use or anything in the actual AI realm in general?
Um, I have opinions that are very ill-informed about that. Like I think most people, I'm really interested in those issues, but I don't feel like I have a lot of real expertise. I guess I am worried about the sort of laissez-faire view that we should just let the industry do whatever it does. Or even more, what seems like what, like the fight between the administration and Anthropic, because Anthropic doesn't want its AI used for, really bad purposes. So I'm worried about that, but I have really not, I don't, I don't think I understand AI well enough to be able to say, what's a reasonable way to regulate it. And I've heard, people who really sound smart and know what they're talking about and have very different views. So I feel a lot more confident about the sort of simple nuts and bolts side of the thing than about the actual AI. I think the other problem is we just don't know. We still don't really know, like, where AI is going to be in a few years, which makes it hard to know, like, what kinds of regulations make sense. So, yeah, I think that's a harder part of the problem.
Thank you.
Yeah.
Hi, I'm Frederick Neary. I'm a student at Lehigh, part of the ESE program. And so I'm not as knowledgeable about this, but I was actually just talking about with my dad the other day because he was a mechanical electrical engineer and he used to run a power plant near me. And he told me how the power plant actually used a closed loop water source so that it didn't actually have to pollute back into the local environment. So after it used the water, it would let cool down and then they would just reuse the same water over and over. Now, I'm not that knowledgeable about how that works, but I was just wondering, how come the AI data centers can't do that? And if they are doing that, why isn't it just implemented on a national scale as a regulation? Because to me, it just seems as something that would really solve one of the main concerns about water pollution, because I feel like we hear that a lot in the news and on social media and such. And I don't know if it's blown out of proportion or if it's true that it's such to a degree that it's really causing harm to the environment, but that's just my question.
Yeah. So I don't know as much about the closed loop cooling systems as I probably should. And I guess what I don't know is whether you can do that forever or whether at some point you know, you need to flush out the system and put in new water. But it certainly reduces the problems. Also reduces the problems you have. Well, I haven't really focused on it, but when you're pulling all millions of gallons of water out of, like, a river or lake, you're gonna, there are a lot of fish and whatnot in the water, and basically you got to screen them all out. And so you're going to have a large kill rate. And that's also a concern. And the closed loop really helps with that because you're not continually pulling water into the system. I think utilities have been so I don't know specifically data centers. Utilities have been resistant to the closed loop thing on cost grounds, right? It's just more expensive. And I assume that remains a source of resistance. EPA tried to mandate that and got pushback from the courts. But that does, yeah, and that also would reduce the amount of the water consumption issue, right? So, and it may well be that that's where centers will end up, even though it costs them more money.
And then my additional question onto that, if I may. Near me, actually, in my home in New Jersey, they're actually building an AI data center next to a retired power plant that does use the water closed loop system. So I was
Uh-huh.
wondering if power plants are already using that existing infrastructure, can the AI data center be added onto it? And is that like the path forward, maybe? Like retired power plants or such that are using these closed loop water systems to build the AI data centers right nearby so that they could access the power and access the water that they need without contributing too much harm to the local environment.
Yeah, I mean, the problem is that retired power plants are usually retired for a reason. And often the reason is that, well, we have a very old power plant fleet in many places, right? The power plants, I think were originally estimated to have like 30, 40-year lives, and now we've got them running twice as long or more. Um, um, so, so we have sort of basic issues there. But the other problem is that at some point the environmental upgrades start being more expensive than it's worth when it's just cheaper to close the thing down and start over. And so I think one of the big concerns is, if we restart these power plants or if we keep power plants open that we're planning to close, we're also perpetuating environmental impacts from the other impacts. They may be good on water, but they may be emitting a bunch of air pollution at the same time. Um, now, another area we don't really know for sure what's going on with the technology is nuclear, right? So there's a big push towards small modular reactors and other, new reactor designs. If that works, it could be, and if, they may or may not be water cooled, but however they're cooled, you may be able to sidestep, you've got other potential environmental problems, but you could get rid of the air pollution and, some of the other issues that we've been talking about. And you might be able to pair, I think there's some interest in trying to pair those with data centers, right? So, but that's not going to happen overnight. Even if you can get it permitted today, building it, testing it, getting final approval to operate, it's going to take a number of years. So it still leaves us with this interim period.
All right, thank you so much. I really
Yeah.
appreciate it.
I also want to contribute to something. My name is Panashe. I'm part of the ESE program. Frederick just asked a question that reminded me of a seminar that we did last semester. I think Albert was part of the panelists where we were discussing how to make data centers energy and water efficient. And a lot of discussion came up where we are using these closed loop systems and direct-to-chip cooling systems as a way of making these data centers water efficient. And what I understood was these data centers, they use a lot of water. So it's more like now they are competing with the environment. Now the people want to use the water. The data centers want some water. So the closed loop system was a way of making them water efficient so that we don't have to use the water then discharge it, right? We have to use the same model where we are, when they go to cool the chips, they get heated, then we cool the water back to a lower temperature, then we continue using the same water. Then after some time is because when we are heating the chips, they steam. I say that it's some water is lost through evaporation, then we add more water to the system. But I think the continual use of the water will actually reduce taking more water from the environment, which I think is a really good move.
Yeah, no, I agree with that. I thought EPA was probably right when they tried to mandate it for utilities, even though they weren't able to make that stick. But it does seem like it would help with a significant part of the problem. But again, it may be more costly. So at some point, I guess either regulators or the industry is going to have to decide, is this a good trade-off? Are we willing to pay more in order to avoid the environmental harm? And it may well be that they are, because they want to build this stuff quickly, and so it's worth money to them to just not have a controversy over what cooling system, right? I know. But on the other hand, if they don't have to spend the extra money, they probably, if they are in business. So I would not be surprised, I guess I would say, to see an increasing use of closed loop systems, both by the data centers themselves. I think that's probably the more obvious one, but also by whatever new generators come online to try to serve their demand. But that may be more, it may be harder to get people to focus on the indirect water use, that is the use by the generators, and connect that with the data center. That, requires kind of a leap of the imagination as opposed to what the data center is actually using on site. But yeah, no, I guess I guess the short answer, the short version of what I'm saying is yes. That does seem like, in general, a good solution, assuming that the economics work.
All right, another follow-up. So I just remember something. You saying they're in business, so they are going to do whatever that costs them less money, right? So which reminded me of something like some of the companies, they look at the fines that they have to pay, like if the EPA fine them for let's say for example, some chemical companies, they discharge their waste into their water bodies, and they have to pay like an annual fine for that. Then they also look at the cost of treating the water before discharge. Then now they see that it's actually expensive to treat the water than discharge it into the environment. Now, instead of treating the water before they discharge it, they just discharge it, then they pay the fine. So my question is, do we have any policies that bans or that do not allow companies to discharge the water before they treat it first? Like if it's a matter of profit, I'm just gonna discharge the water just like it, then I pay like let's say a $2 million fine, than incur a $4 million cost of treating the discharge.
Yeah, no, good, great question. The fines are supposed to be designed in a way that, eliminate that profit motive, but I don't know that they really are. That the fines may or may not be big enough in some cases to do that. There are other remedies, though, for violations. So you might be able to get a court order requiring them to stop discharging or to install a treatment system or something like that. So although it's true to an extent that they can just go ahead and pay fines, that has its limits, and at some point they may be faced with a more serious and also potentially criminal charges for intentionally violating the law. So there's at least I think a threat that you might not be able to just treat the fines as a cost of doing business. I think there's also another factor, which is that the companies have an interest in sort of generally appearing to be trustworthy and law-abiding and not, and non, and like good members of the community, both because it's difficult to operate if everybody in the locality hates you. There are still a lot of things local governments, for example, can do to make life more difficult. And also because, after all, these companies want us to trust their products. And if, to the extent that they get public reputations as being untrustworthy, that's harmful to sort of their general effort to sell what they're doing. So I think also there's, because they're in a position where they're very much in the public eye, I think there's also some other pressures for them to comply with the law that might not be as much true in other industries. Having said that, however, I think in part we just don't know. There's been a big dispute in Memphis with Elon Musk. So Musk has a big AI facility in Memphis. I don't actually know if it's in the city limits or just outside, but it's in the Memphis area. And to get the thing up and running, the company brought in, I think, 25 natural gas portable generators to generate the power to keep it going. And they didn't get permits. And then they came under a lot of pressure and applied for permits, and but not for all of the generators. So there was a dispute. And, I guess without going into the gory, and now they're being sued, right? So it kind of looks like they decided to just go ahead on the assumption that, the government wasn't really likely to stop them from operating, and that they could work out any legal details later. So that's sort of a counterexample to what I was just saying about trying to appear to, doing your best to appear to be a good citizen and so forth. Although I'm hoping that the other kind of incentive to present yourself as trustworthy and law-abiding and so forth will dominate. I'm not sure, say in Musk's case, whether he wouldn't be willing to just keep on paying fines forever and polluting. So more question marks.
Go ahead. Hello, Mr. Farber. My name is Eunice Katzima. I'm part of the ESE class. My question is on, we mentioned that the federal government is more for energy security than for sustainability. But how would the legal principle of federal preemption interact with states like California? Because I know California is aggressively pushing towards zero carbon mandates. And one of the biggest things they're focusing on is decarbonizing energy that's coming from data centers. So there's clearly conflict here between the federal and the state. So which one is going to take, to be more effective, or what we're going to follow going forward? Are we just going to focus on the state or the federal?
That's a big and somewhat complicated question. The line between federal state authority is often not clear. So I'll just give you my view rather than, present all the arguments. I think that California has a lot of power, a lot of authority to regulate power sources used within the state of California, and the operation of data centers within California. I'm not talking about the AI, sort of regulating AI, which raises different possible issues, but just regulating the sort of physical side of things, the environmental side of things. The Trump administration is pushing hard to bring preemption claims and try to limit California's authority. And at least my view is that they won't be successful. That's the way both the environmental laws are written and the Federal Power Act is written, the states really do have the ultimate say about the generation mix, right? That being said, it's going to be a fight, and you can never 100% predict what the courts will end up doing. But at least my view is that on the generation stuff and on the siting stuff, that the states are, have the primary decision-making power.
Thank you.
Other questions from students? I see a question in the chat from DC. I don't know if he's a student or not.
That's Dan Chapley.
Okay. Thank you, Susan.
You're welcome.
Um, So before I move to those ones, let me just give another 30 seconds for the student questions. Okay, so forever hold your peace now. I'm going to be reading the question from Dan. So it says, since the vast majority of global data centers are in the US, what legal political arguments would one present to have a state or even a locality 1-1? Very few employees are employed at these data centers, but the output from the data centers is used by the global IT enterprise. Seems like minimal benefit to the local population, slash local grid, slash local water usage, slash local noise created, slash local pollution.
Yeah, I think that's a real question. I mean, they've tried to sell, I mean, I guess as long as you're building them, you have a benefit for the construction industry, right? And other, sort of things that are supporting the construction, which, you know, might be considered a significant benefit. I don't really know how that, how the numbers work on that. But I think primarily what you're getting is something you can tax, right? You can, both in terms of income tax, you can try to attribute some share of, I don't know, Google's income to the data centers within your state and impose a tax on that, and property taxes from a very major facility. But I agree, it's not the kind of thing that produces like continuing, a significant number of continuing jobs, for example, um, in the locality. And I think it's even more true at the local level than at the state level, that you're not getting a lot of the benefits that would probably end up in the state government's pocket, to the extent that there are benefits, rather than in the county. Um, and so, yeah, if you're, it's not necessarily going to cause you huge problems to have the data center, um, you know, down the road from your farm, but there may not be a whole lot in the way of benefits either. I think what we may see companies doing, um, um, and there's been a lot of thought about, so there's been a lot of thought about this also in terms of renewable energy, right? So if you have, it's sort of similar if you have a big solar farm down the road, right? It doesn't create as many externalities for you as the data center might create. It's not using a bunch of water or whatever. But on the other hand, it's, not bringing in a ton of jobs. It's bringing some money through, some of which might go to a landowner. Um, and so one of the things that renewable people have been thinking about are local community benefit agreements, right? How do you make the project beneficial to the local community so that they do have something to show for it besides maybe just a property tax increase? And if I were a data center company, I would be taking a look at that experience, and trying hard to work out things that will make this a win for the local community. Because otherwise, it's really kind of nothing but trouble. Why not build it somewhere else? Why not build it in a different state or wherever? And that's if you assume it's a good thing to build it, right? Whereas many people, rightly or wrongly, might say, well, if we have one less AI center, that's fine. Yeah. So I think you got to find ways to make this a positive thing. It's going to be very hard to just like, you could imagine a world where the federal government just says they get to build it wherever they want to, and if you don't like it, too bad. And maybe the Trump administration would really like to do that. And even maybe that would be a good thing, but I think politically that's not feasible. And I don't think the legal framework exists to make that happen. You'd have to get like new legislation. So in the real world, I think you probably got to find ways to, um, you know, to win people over.
Thank you. So we have 1 minute left. If somebody has a quick question, and I see there's one in the chat from Adediran. Adediran. Uh, do government looking at standardized AI data center design and construction? This will reduce water and air pollution issues, and potential AI data center owner knows beforehand what is required to build and manage AI data centers.
I don't know that the government's trying to do that actively now. Partly it's difficult because things are so fragmented. Um, and I think it can't be done completely because location matters, right? There's some places where having enough water is an issue and some places where it's not. How much you worry about air pollution may depend on where you're located, et cetera. But I think to the extent possible, I think that's one of the things that over time we may want to do is try, come up with standardized designs so each one isn't a one-off. But I think as with like just building a new I don't know, natural gas generation plant, um, you can standardize some things and those will be easy, but you may not be able to do everything.
Great. Thank you so much, Professor Farber. So we ran out of time now. So again, join me everybody in thanking Professor Farber for a very nice presentation. Susan, or Rudy, I don't know if you want to say anything regarding the next seminar.
Daniel's actually concludes our spring semester seminar series. So thank you for ending it on a great note, Daniel. You did a good job. We will be concluding having more seminars coming up in the fall. So be on the lookout for them towards the end of August.
You guys gonna come for those?
Probably, yeah, you'll all be invited to it, even if you graduate. Yeah, it'll be starting probably around the third week in August it's usually like the first day of classes or the following week after the first day of classes. So somewhere around there.
Right. Thank you so much, Susan. And Susan put for everybody in the chat something regarding an information session for this Thursday. So for those of you interested about the ESE program, you can join there. So there's going to be a presentation in person at 12:30, and there's going to be connection remotely. So again, thank you very much.
Thank you, everyone. Thanks for coming.